seconds to play with technology here. It is a pleasure to be here tonight. I have never figured out why anybody would go out to a lecture at night. I never would. Especially if it was given by me. But thank you for doing that, and we'll try to make it worth your while. Tonight we're going to talk about the title of my book, Bringing Nature Home. And I want to start out by asking you, can you hear me? Is this good enough for everybody? No, it's a little weak in the back. Can you turn me up? Okay. While we're doing that, I want to tell you a story about something that happened to me when I was in 3rd grade. Moved into a new development in Berkeley Heights, New Jersey. And the development was called Oak Park, because oaks are what the bulldozers had knocked down in the development. But we lived in a circle, and our house was the first one to be built in the circle, and then they built them from right to left. So the lot to the left of us was undeveloped for a full year after we moved in. And there was a little pond on that lot. So every day after school, I would go over and see what was happening in the pond. And I didn't know anything about nature at that point, but I discovered that in the spring, this is what happens. Toads come and start to sing. These, of course, are the males. I don't think I knew that either. But they invited bigger toads and gave them a hug, and I thought that was nice. They kept hugging them until eggs came. And then I figured out what was going to happen. Those eggs were going to hatch, and we were going to have pollywogs. And I would get to see metamorphosis. I would get to watch these little guys, their hind legs pop out, and their front legs pop out, and the tail starts to shorten. And it's obvious they're going to become little terrestrial creatures. And I wanted to be there. When I say little, I mean that's what they look like, but they're really little. I wanted to be there the day that those first little toads started their life on land and came hopping out all with big smiles. It must have been a Saturday because I was there hunkered down, and out they came by literally the thousands. But just as they started to hop out, a bulldozer came around the corner and buried that pond. So that was the end of the pond and all of its little toads. It was the end of everything that lived in the pond. It was not the end of the big toads because they didn't live in the pond at that time. But in essence, it was the end of the big toads because they had lost their breeding site. I lived there another 17 years, and I can tell you that was local extinction for that population of toads in that corner of Berkeley Heights, New Jersey. It was local extinction for the dragonflies that bred in that pond. For all the things that happened in that lively little pond. And what's interesting is, of course, what the bulldozer was doing was making the backyard of the house that was to be built next door to me. And I ended up being hired to mow the lawn that then replaced that pond. And the other interesting thing is, they didn't need to do that. To still have a backyard, still have grass. It just was part of you got to get rid of any aspect of nature when you build a development. Although they could have easily lived with it. And of course the problem is that has happened so many times since then, in so many places since then, that we literally are losing the plants and animals we share the planet with. I wish we shared the planet as well as these two birds are sharing a sycamore in my backyard. But we haven't for a couple of reasons. The first reason is we haven't thought we needed to. We thought we could develop any space anywhere, and there would always be a lot of nature left someplace else. So we didn't worry about it. And the reason we thought that is because that has been true through most of our history. The earth was huge, there weren't that many humans around, we really could do anything we wanted locally, and there'd be a lot of nature left someplace else. But almost overnight, that has changed. Now the earth is very small. There are humans everywhere, and there are very few places where nature is functioning as it once did. Second reason we haven't shared the planet very well is that we truly don't see the connection between this lazuli bunting and every other species on the planet and our own well-being. It's not that we don't like nature. We do like nature, but if it disappears, we can watch it on Channel 12. At least that's the way we have treated it. When you think about it then, when we build living spaces for ourselves that don't support life, there's a logical disconnect there. And it could be a signal that our own life support systems are either failing right as I speak or in danger of failing. Either way, it's something we have to be proactive about. We can't wait until our life support systems fail and then start to do something about it. So that's basically what I want to talk about tonight. I want to talk about why we do need to keep other species around. We can call it biodiversity, call it nature. But why we actually do need them. Why we need to change the way we landscape in order to accomplish that goal. Talk about why animals depend on native plants as opposed to plants that evolved in Asia or Europe. And then finally, we'll talk about how to make our landscapes sustainable. I used to have the word more in there, how to make our landscapes more sustainable, until I thought about what the word sustainable means. Being sustainable is like being pregnant. You either are or you aren't. You can't be halfway sustainable. And right now, our landscapes are not sustainable. They do not sustain life without a whole lot of input from us. So that is not fitting the definition. So what can we do to our landscapes to make them truly sustainable? Let's start with the definition. What is biodiversity? You hear this all the time, and there are actually 14 different definitions of biodiversity. Let's just go with the simplest one. It's every species that's on this planet, including us. And because there are a lot of species on the planet, and actually because there are fewer every day, we might want to ask the question, how many do we need? How many do we as humans need in order to remain happy and healthy? And this turns out to be a question that ecologists have been asking since the mid-50s. A guy by the name of Bradford, one of the greatest ecologists of the 20th century, gave us what he called the law of nature. He said that as you increase the number of species in an ecosystem function goes up. Now, we didn't talk about what happens as we decrease the number of species in an ecosystem, but you can see this is pretty easily reversed. If you take species away, ecosystem function is going to go down. And he advanced this at a time when doing large-scale, long-term ecosystem studies just didn't happen. So this was never really tested. He called it the law of nature. It sounded good, so we all believed it. And then through the years, other hypotheses were advanced. But in 2012, 3 studies were published independently that had conducted long-term manipulations of ecosystems to test this hypothesis. And it turns out that, at least according to these 3 studies, MacArthur was right. As you increase the number of species in an ecosystem function goes up. And of course, as you take those species away, ecosystem function goes down. So how many species do we need in our ecosystems? How many species do we as humans need? We need all of them, because we need all the ecosystem function we can get. That is why we need biodiversity. It is why we need nature. It is nature that is running our ecosystems. When you have a diverse ecosystem, it is more stable. So if it's perturbed, it returns to its original state faster if it's diverse. It's better at performing biogeochemical processes, things like sequestering carbon or cycling nutrients. Increases ecosystem productivity. Now, you can define productivity any way you want, but let's define it in terms of ecosystem services. Those services that keep humans around. When you have a diverse ecosystem, we get more ecosystem services. And diverse ecosystems are less susceptible to invasions by plants and animals from someplace else. And those are all good things, so that is why I have been running around the country trying to convince people, just like yourselves, that the plants and animals around us are the rivets that hold our lives together, hold our ecosystems together. Our environment. Don't think of it as the environment, as if it's something you can take or leave. It's yours, it's the only one you have, and that is what sustains you. It's not the mall that sustains you. Maybe it is the mall that sustains you, but everything that's in the mall comes from a healthy ecosystem. Why is that? Because it is biodiversity. It's all the species out there that are creating those ecosystem services, and the mall is not creating any ecosystem services. There was a huge study in 2005, the Millennial Ecosystem Assessment, done by hundreds of scientists from around the world, that had a single question. They wanted to know what we humans have done to the Earth's ability to produce the ecosystem services that we absolutely need. And as of 2005, they concluded we had already degraded 60% of the Earth's ability to produce those services that we need to stay alive. Which is not good news, because every time we add a person to the planet, which we're doing 3 times a second, we need more ecosystem services to support that person. Instead, we are getting fewer. So this is something we need to turn around as soon as we can. Just a quick review of what an ecosystem service is. How about oxygen, production of oxygen? It's plants that make oxygen. It would be nice to keep oxygen on the planet. It's plants that clean our water, that hold it on the land surface so it doesn't rush to the ocean and get salty, and allow it to infiltrate so that it restores our aquifers. Plants are doing that. They're doing it all for free. They're also building our topsoil and holding it in place for free. They are preventing floods for free. If we leave them on the landscape, and we're not too good at doing that. As a matter of fact, they buffer extreme weather events. When you have well-vegetated ecosystems, you don't have events that look like this. Or if you do, they are far rarer than if you denude your landscapes. We're getting a lot of extreme weather events these days, so this is something we might want to think about. Carbon sequestration. This is a ceiba tree in the forest of Costa Rica. It is 600 years old, and it is built out of carbon that has pulled out of the atmosphere and has locked up in its tissues. So that carbon is not up in the atmosphere warming anything anymore. And it's what all the trees are doing out there. One of the reasons that trees matter. This is a big guy. That's 18 people standing at the base of the tree. And the only reason the Costa Ricans hadn't cut it down is that it was too big. They couldn't cut it down. So planting trees like this, we should be putting trees like this all over the planet as fast as possible. Although we are not taking advantage of this. We are still deforesting the planet at a rate of 50,000 acres a day. I'm not going to offer trees as a permanent solution to our carbon woes, but I'll take a 600-year solution any day. I'll take a 100-year solution. Just something to slow the rate of the carbon that's going into our atmosphere. A third of the carbon that's up there now has come from the trees that we have already cut down. Cut down half of the forests that are on the planet. What do animals do for us? They recycle our garbage. You know, there's a gyre of garbage floating in the Pacific, which is 2 times the size of Texas. And it is the depth of the Empire State Building. We make a lot of garbage. We need to recycle that. We need to have seeds dispersed from their parent tree. That's what animals are doing. Really important ecosystem service that people don't think about. If those seeds remain underneath the parent tree, chances are they're not going to germinate. So seed dispersal is really important. Pest control is really important if we keep the predators in place. And pollination. You hear a lot about pollination because it is so completely vital. 80% of our plants are pollinated by animals, not by the wing, and 90% of our plants, or of the angiosperms, the flowering plants, are pollinated by animals. So if we lose these pollinators, we are going to lose 80 to 90% of our plants. And that is simply not an option. Not when you have 7.2 billion people on the earth. We need all the plants we can get. Another ecosystem service that we're just starting to hear about is that apparently it's turning out we need to interact with nature, with other living things, particularly when we're young, for healthy mental development. And this message is being promoted by Richard Louv, who wrote Last Child in the Woods, and he coined the term nature deficit disorder. He says that our kids are not out playing in nature anymore, and at the same time they're suffering from elevated levels of ADHD and childhood obesity and childhood depression. He says maybe there's a connection between the two. Let's do some research, see if there's a connection. What are our kids doing? Well, they're doing what we're doing, or we're doing what they're doing. Whatever it is, it's electronic, and it typically means they are inside. But Richard Louv also says that our kids are the future stewards of the planet, and we don't have to do any research to prove that that is true. And he says that they don't develop an emotional relationship with the things they're supposed to be stewarding, they're going to be lousy stewards. So he says, let's get the kids out of the house, and run out of that bed, turn over the rock, and play with the sound. Yeah, that's my granddaughter, so I can show. And I couldn't agree more. That the kids need to get out of the house, turn over that rock, if there is a rock. And unfortunately, we have sterilized our neighborhoods, our yards, to the point where there won't be a salamander under that rock anymore. We have removed nature from the lives of our kids, from our own lives. We've gone one step further, unfortunately, and demonized nature. So now, not only is it gone from the lives of our kids, but they're afraid of it. They're afraid to go out of the house because something evil will happen to them. So our kids have nature deficit disorder in large part because we have a deficit of nature. The good news is we can put it back. We can put it back into our kids' lives, into our neighborhoods, if we understand where it comes from and how to manipulate it. So where does animal diversity come from? Well, it comes from plants. And the more plants you have, the more animals you have. And that's because of this relationship that we will make simple here. This is photosynthesis. It's actually very complex. If anybody had to memorize the formula for photosynthesis in high school, you remember. We're going to make it easy. Plants, of course, are the only organisms on the planet that allow us and everything else to eat sunlight. It's another ecosystem service. You take plants away, we're going to have to eat sunlight without it. And we talk about technology solving all our problems. I don't want to count on How does this work? Well, plants, of course, gather carbon dioxide from the air, combine it with water from the ground, producing the oxygen that we all still need. And now the energy from the sun is locked up in the carbon bonds of simple sugars and carbohydrates, which happens to be the basis of every food web on this planet, with the minor exception of some sulfur-based food webs at the bottom of the ocean. And I don't want to rely on them. So let's generalize and say plants are making all the food. And I want to emphasize, not just for us, but for everything. They also have physical structure. So they are providing the shelter, the housing for the animal life that is out there. So quite literally, plants are a matter of life and death for animals. If you have them, you have the option for life. If you don't, you don't. Where don't we have plants? Well, there are no plants right here. Every time we build a building, there's no plants. Every time we pave a road, there are no plants. So there's a lot of places we have removed all of the plant life, which means we removed all of the animal. But because now we know that plants are in charge of everything else above them, we can look at the amount of plant life in a given space and estimate what the carrying capacity of that space is. Now, carrying capacity is just an ecological term that describes the amount of life that can be sustained in a given space, essentially forever. That's what sustainable means, because it's not degrading the resource base of that particular space. Let's plot this. Let's say we've got that many plants, and that's determining the carrying capacity of this particular place. And if you think of carrying capacity as if it were the principal in an ecological savings account, it might be easier to understand. But you have to remember, when we had savings accounts, they used to generate interest, and we could live off that interest forever as long as we didn't dip into the principal. That's how it worked. It's still how the carrying capacity works. You have plants making ecological interest in the form of food and shelter, and animal populations can grow and cycle using that food and shelter forever, as long as they don't reduce the amount of plant life making the food and shelter. If something does reduce the amount of plants in a given area, of course there'll be less food and shelter, less ecological interest, so any animals depending on that will crash down below the new carrying capacity. And of course, if you get rid of all the plants, you get rid of all of the food and all of the shelter and all of the animals. This is an eastern deciduous forest. Exactly what we have, at least back east. I think it's pretty similar to what you have in your forest around here. Very high carrying capacity, because it's making so much food and so much shelter compared to a suburban yard. For obvious reasons, we've taken the plants out of this space. It's true, that's a plant and that's a plant, but it's a tiny fraction of the plant life that used to be there, generating just a tiny fraction of the ecological interest of food and shelter that used to be generated there. So it's supporting just a tiny fraction of the animal life that used to be supported there. If this were the only suburban neighborhood in North America, we wouldn't have to talk about it. But it forces us to ask the question, what have we done to the carrying capacity of the U.S.? And I like this picture. It's from a book by Sanderson in 2009 about the ecological history of the island of Manhattan. And this is what it looked like 400 years ago, when it sustainably supported a population of 600 humans. All the plants were there, had a very high carrying capacity, and everything those 600 humans needed, they got from Manhattan Island. And they had for who knows how many thousands of years beforehand. And this, of course, is what it looks like today, when essentially all the plants are gone. Now, given this talk in Manhattan, and they get mad at me because they say, we've got Central Park, and a tree grows in Brooklyn. It's okay. There are some plants there, but it's really not many. So the carrying capacity is very near zero if it's not zero. And yet, we've got some 8 million people living in and around Manhattan, in and around the metropolitan area. How can you have 8 million people living where the carrying capacity is zero? Well, you could do that because ecosystem services move around. So the people of Manhattan get their oxygen from all over the world. They get their food from all over the world. They get their water from the Catskill Mountains. They send their garbage to New Jersey. I was born in New Jersey. It works for the people of Manhattan and Cedar Rapids and every other city on this planet, as long as you have functioning ecosystems someplace else to make the resources that those people need. What worries me is that there is no global plan to make sure we have enough functioning ecosystems to handle our burgeoning populations. And of course, it's not just Manhattan where we have replaced most of the native plant communities that used to be there. This is what development looks like from the space shuttle at night in the U.S. We are pretty much everywhere. We've taken 950 million acres east of the Mississippi of virgin forest, cut it all down. We were an agrarian society, and then we weren't an agrarian society. Many people moved into cities, and many of those forests grew back into what we now call secondary forest structure. All the forests we see around us are secondary forest growth. But many of those are good places to live, and many of those trees are over 100 years old. The problem is we haven't stopped growing. We're still adding 5,700 people to the U.S. every day. And those people need a place to eat, or a place to live and something to eat, so we're sprawling, and we are fragmenting that eastern deciduous forest. So now when I fly home and I look down out of the plane, that's what I'm going to see. I see little habitat fragments. And the question is, are those fragments big enough to maintain the biodiversity that we need to run our ecosystems? We have 4 million miles of paved roads in the U.S. If you calculate the surface area of those paved roads, it's equal to 5 times the size of New Jersey, paved over. If pavement were a functioning ecosystem, that'd be okay. But it's not. And of course, we have a love affair with the lawn. 45.6 million acres of lawn, 72,000 miles of lawn. We're adding 500 square miles of lawn to the U.S. every year. And that's over 8 times the size of New Jersey that looks like that. So lawn is alive, but it is not a diverse ecosystem. It is not doing all the things that we need our ecosystems to do. So we've got to give up this notion that there's a lot of happy nature out there anymore. We're talking about human-dominated ecosystems from coast to coast. 52% of the U.S. is in some form of agriculture. This is what it looks like over Michigan, and I think it's what it looks like over Iowa as well. And here, the carrying capacity has all been funneled towards making food and fiber for humans. So that's a large portion of the U.S. that is essentially out of commission at this point. 43% of the U.S. is in what I call the suburban-urban matrix, this matrix of cities and suburbs. And embedded in that matrix are these habitat patches that we have left. That leaves only 5% of the U.S. that's relatively pristine. Which is not, and that's typically mountaintops and deserts. It's not nearly enough to supply the ecosystem services that we need. So we essentially have converted the natural world into the cities and suburbs and agriculture that support our populations and our way of life. This is a house down the street from me. I'm not going to make a value judgment about whether or not we should do that, convert the world into human-dominated landscapes. Because I'm too late. We've already done that. But I am going to make a value judgment about the way we have done it. This is a house down the street from me, and it's what all the houses down the street from me look like. It was built, this landscape was built for convenience. It was built to meet the aesthetic needs of this homeowner. It was built to celebrate lawn as a status symbol. But it was not built with the idea of sharing this space with any other living thing other than turf grass and Bradford Pears. But it could have been. That's my point of this talk. This homeowner could decide to share this space with other living things, and if he or she did or does, it's going to be a rewarding experience. We're not talking about a sacrifice here. So I am not suggesting that humans disappear from the earth. I would get very few talks if I did that. But I am suggesting that we share the earth. And if we refuse to share the earth, I'm predicting we will disappear, because we need natural systems to keep us going. What's happening to those natural systems? What's happening to some of the species that I've been talking about? Let's just talk about Neotropical migrants, the birds that breed in North America, that move to Central and South America to spend the winter. 127 species are in steep decline. We now have 50% fewer birds today than we had just 40 years ago. Does anybody know what that bird is? That's good, because 96% of their population is gone. So anybody who knows what a bobolink is has good eyes. So this is the problem. We're losing our biodiversity. And our biodiversity are our natural capital. That is what we have been living on. We don't want to lose capital of any kind. So we've got to come up with some ways to keep these species around. Bottom line here is that biodiversity is an essential, non-renewable natural resource. It's essential because we absolutely need it to be sustained on this planet, and I don't mean for 5 years. It's a non-renewable natural resource, because if these species go extinct, they are not coming back. And yet that's what we're doing. We are forcing them to extinction. Why is that? We have parks, we have preserves. Part of their mandate is to keep these species around. It's not working. Why not? A couple answers. The simple one is that they are too small. They're too small because when we take a large habitat and shrink it down to a small habitat fragment, we're taking large populations that are in those habitats and shrinking them down to small or tiny populations. And that's the problem. Tiny populations are highly vulnerable to local extinction. Why? Because all populations fluctuate. Good times that go up, bad times that go down. If you're a large population, even in your down cycle, there's enough individuals so you can rebound quickly when times get better. But if you're a tiny population, often in your down cycle, you disappear. You hit zero. You blink out of your little habitat fragment. And then, unless you recolonize that fragment, which is difficult to do these days, you're permanently gone. So that's called local extinction. There are studies from all over the world that have been looking at this, and some of these are quite long-term studies, over 100 years in length, and they're all saying the same thing, that our natural areas are no longer large enough to sustain the nature that we need them to sustain. And unfortunately, that includes our largest national parks. That's a lot of bad news. So let's talk about some good news. The good news is we can turn most of this around if we simply decide to start to share our spaces, our lives with nature. If we share our lives with nature, we really can save it, and that means we will save ourselves. But, again, we're going to have to put nature right where we are living, right where we're working, and to a better extent, right where we do agriculture. Let's just talk about where we live tonight. Let's talk about our neighborhoods. Our neighborhoods, our yards, were not designed to support nature. They were designed to look like postcards that never change. That was the goal. We've done an excellent job of that. And as we already discussed, in doing so, we removed so many of the plants that used to be there. So our challenge is to raise the carrying capacity of where we live by putting the plants back. It sounds simple. If we put enough plants back, we can recreate functioning ecosystems again. Will they be exactly like the ecosystems that were there before we humans came? No, they won't. We've changed too many things. But is that the goal? The goal is to create ecosystem function. It's not to turn back the clock. Can we create ecosystem function even if they're not exactly like they used to be? Yes, we can. But is that all we have to do? Just add plants? Well, think about why we're adding the plants. We're adding plants because they're supporting the food web that we're trying to reestablish. And unfortunately, all plants are not equal in their ability to support food webs, which means we have to put the right plants back, or it's not going to work. Here's an example. This is autumn olive, genus Elaeagnus. It was brought over as an ornamental plant about 120 years ago from Asia. Has since escaped and is now what we call an invasive species, which means it is displacing native plant communities. And it's doing that so aggressively, particularly up and down the East Coast, that many folks are calling it Uglyagnes instead of Elaeagnus. And that's okay with me. But Uglyagnes, we might not want to call it Uglyagnes if it were the ecological equivalent of the native plants that it's displacing. Our ecosystems would look different, but they would function just as well. So that's the question. Is Uglyagnes and all the other invasive non-native plants that we have released in this country, are they as good at doing all those things we just talked about as the native plants they're displacing? And that really is what my research has been about for the last 10 years, particularly in terms of their ability to support food webs. And in the case of Uglyagnes and everything else we have measured, no, they are not as good. As a matter of fact, they are terrible at supporting food webs because they are terrible at supporting local insects. And whether or not you like insects, you cannot remove them from your local food web without that food web collapsing. Here's an example. This is a hedgerow in Maryland. I had an undergraduate student measure caterpillars in hedgerows just like this in Maryland, Pennsylvania, and Delaware. And she compared hedgerows that were invaded with plants from someplace else, from outside of our local food web. That's what non-native means. With hedgerows that were not invaded. They were almost entirely native plants. So here we have Uglyagnes and many other non-native plants. We've got Uglyagnes and multiflora rose and Japanese honeysuckle and bush honeysuckle and porcelain berry and miscanthus and ailanthus and Norway maple and Bradford pear and privet and barberry and burning bush and you name it. And guess what? They're all escapees from our garden. 85% of our invasive woody plants are escapees from our garden. So let's compare the caterpillars in an invaded hedgerow with one that is not invaded. You find 5 times more species of caterpillars in the uninvaded hedgerows, and 22 times more caterpillars themselves, which means that the plants that are largely from Asia are very poor at supporting local caterpillars. So now the question is, does that matter? Who cares? Well, it matters if you eat caterpillars. Like this common yellowthroat is doing. This guy is trying to feed his babies as they're on the ground here in a nest. And if he's in a habitat overrun with ugly agnes, he's going to have to forage 22 times harder to get the same amount of biomass, of caterpillar biomass for his young. Are you trying to tell me something?
I'm waiting for the sign-in sheet.
Oh, okay. Sorry. I was giving a talk not long ago. 3 firemen came down. All dressed. Yeah, they threw us out of the building. There was a carbon monoxide leak. So. All right, this guy is not going to be able he's not going to be able to forage 22 times harder to get the same amount of food that he used to get before these plants displaced the native plants that are good at making caterpillars, because he's already foraging all day long. 156 trips a day, 1 trip every 5 minutes. You can't ask him to do that 22 times harder. So the prediction is that when you displace native plant communities with non-native plant communities, you will lose 22 times the amount of insectivore biomass, bird biomass, or anything else that is eating insects. What happens when we put exotic ornamentals in our yards? This is what we're landscaping. To test this, we went to Michael Blair's Managed Marine Landscape Plants, and he suggests that we landscape with 69 genera of plants from someplace else. I call them out-of-towners. And 101 genera of native ornamentals. And what we did then was go to the literature and look up the number of species of caterpillars that could make a living on each one of these plant genera. And on average, we found 4 species could make a living on the out-of-town ornamentals, and 72 species on average could make a living on the native ornamentals. Which means if we landscape primarily with these guys, and we all know that we're doing that, we lose a tremendous amount of insect diversity and insect biomass. Now, why can't our insects eat ugly agnes and multiflora rose and all of those guys from out of town? That's a good question. The answer is that plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction, so they have loaded their leaves with nasty-tasting chemicals, secondary metabolic compounds that make these leaves either bitter or downright toxic. And it's a very successful defense mechanism. It keeps most of the insects of the world from eating most of the plants. And that's why you can look out the window in the summertime and it's green. It's not because there's nothing out there that wants to eat those plants. It's because most of those plants are chemically unavailable to the things that want to eat. They're highly distasteful. But we do know that insects eat plants, so how do they do that? How do they get around all of these chemical defenses? Well, they do it by specializing. An insect lineage will pick a plant lineage over evolutionary time, and it says, okay, I'm going to get good at getting around the particular cocktail of defenses that this particular plant lineage is making. I'm going to develop the enzymes and the physiological mechanisms and the behavioral adaptations and the life history adaptations that allow me to eat this plant without dying. But it takes a long period of exposure to that plant lineage for all these adaptations to fall into place. Here's an example. This is eastern red cedar, and it defends its tissues very successfully with a toxic monoterpene called beta-thujaplixin. Beta-thujaplixin has been so successful at defending eastern red cedar tissues from insects that very few insects, even after millions of years of exposure to this, have been able to adapt to this particular tree. So here's one that has this. Is the juniper hair streak. It is a specialist on eastern red cedar. It has developed the enzymes and the physiological mechanisms to be able to eat beta-thujaplixin without dying. And that's the upside of specialization. The downside of specialization is that in developing the adaptations that allow it to succeed on eastern red cedar, it has not developed the adaptations that allow it to eat oaks or grasses or lilacs or anything else. It is locked in to the plant lineage that it's specialized on. Which means if we don't include eastern red cedar in our managed landscapes, we will lose this species. If you're going to eat eastern red cedar, you might as well look like it. Everybody see the caterpillar there? Right there? There it is up crypsis, blending in with what you eat so the birds can't find you. This is the double-toothed prominent. It actually is much greener than this, but the flash of my camera lights it up so that it looks white. It is an elm specialist. So not only is it good at getting around the chemical defenses of elm, it's good at looking like the edge of an elm leaf. Why does it want to do that? Well, it's trying to hide from the birds that are trying to eat it. And you might think that birds hunt caterpillars, but they don't. They hunt caterpillar damage. They're looking for holes in leaves. So this guy's game plan is to sit in the area he just ate, pretending he's the edge of the leaf, and he says, there's no holes here. And the bird flies away. And it's great for the double-toothed prominent as long as we have elm. But if the Dutch elm disease comes along and takes out our elms, or if we don't plant elms and we plant ginkgos or something like that, we will lose the double-toothed prominent, because that's all it can eat. And this, of course, is the monarch butterfly. It is a specialist on milkweeds. And specialization has become its curse in recent times because milkweeds are disappearing. Actually, it's not specialization that is the curse. We are the curse of the monarch butterfly because we are taking milkweeds out of our agricultural and other human-dominated landscapes. And this is a good example of how adaptation works and doesn't work. A lot of people say, well, first of all, let's just review how much trouble the monarch is in. There's only 3.6% of the monarchs left compared to what was the size of the population in 1976 when they first found the overwintering population in Mexico. So we've lost 96.4% of our monarchs at this point. They're in trouble. They're that tiny population. So now a bad weather event or almost anything can tip them into oblivion. And the people that say, well, they'll just adapt to something else, I am waiting. They're specialists on milkweed. Do we want them to adapt to corn or soybeans? I don't think that's going to happen before they disappear. It's just not the way adaptation works. And this, of course, is how we're farming here in the Midwest. We've got Roundup-Ready corn and soybeans. So it's clean farming technique. The milkweeds are gone certainly from within the field, but also from outside of the field. We really need to have some not just milkweeds, but all the flowering plants that used to be there. Out here, they're not going to reduce yields at all. It will keep our native bees around. Our monarchs will be able to rebound if we get these milkweeds back in our landscapes as soon as possible. A single farmer doesn't make a difference, but when you do it over tens of thousands of square miles of the Midwest, it makes a huge difference. What can homeowners do right now? Get the milkweeds in your private gardens, because that can have an immediate benefit. But it's not just caterpillars that are specialists. This is the elderberry beetle, only eats elderberry. This is the dogbane beetle, only eats dogbane. This is the sumac flea beetle, only eats sumac. This is a leaf-footed bug, a Korean bug that only eats ash. So the emerald ash borer is here in Iowa. If it kills all of the ash trees, this species will disappear. The great ash sphinx will disappear. The wave sphinx will disappear. I think there's 44 species of caterpillars that only eat ash. They will all disappear, and that's the problem. 90% of the insects that eat plants are specialists, just like the ones I just talked about. So if we bring in a hodgepodge of plants from around the world, mostly for landscaping, which is what we're doing, and it's what ecologists now call novel ecosystems. Novel meaning these plants have never interacted with each other or with anything in their new environment, so they have no specialized relationships with anything around them. If we continue to do that, we're going to lose 90% of the insects that eat plants. Who cares? Typically, it's not gardeners who care. Gardeners have been trying to grow their plants in insect-free space ever since we started gardening for aesthetics, because we don't want them to eat our decorations. We think of plants as decorations. So I understand that. But who cares if we lose our insects or all the things that eat them? And it turns out it's a lot of things that depend on insects. Like all spiders eat insects. They eat other things that eat insects. Tremendous diversity of insect predators that eat insect herbivores. We would lose all of them. We'd lose our frogs, our toads, all of the amphibians because they eat insects. Even our freshwater fish. 60% of the protein that drives freshwater fish populations comes from terrestrial insects that fall into the water. Our lizards eat insects. Our bats eat insects. Our rodents eat insects. Why? Everybody thinks of rodents as seed eaters, and they are seed eaters when they can't get enough insects. But they're eating insects because insects are really good food. Does anybody raise hamsters anymore? We used to do that. Who's got a hamster? Nobody. Too bad. Take a grasshopper and throw it into the hamster cage. Your hamster will never have seen one before. But watch what happens. It jumps on it like, it is the best day of its life. Why? Because insects are super good food. Pound for pound, there's twice as much protein in insect meat as there is in beef. And they have organs in their abdomen called fat bodies that are loaded with lipids that allow these little guys to grow quickly, reproduce quickly, which if you're a mouse you want to do because there's so many things that want to eat you. But it's the same reason that larger organisms are eating insects. The skunk is digging up your yard to get the grubs that are in your yard. Possums eat a lot of insects. Raccoons eat a lot of insects. Almost everything does. And even things we don't think of as insectivores eat a lot of insects, like red foxes. 25% of a red fox's diet, a full quarter of a red fox's diet is insects. 23% of a black bear's diet is insects. And even things that don't eat insects rely on insects. This is a sharp-shinned hawk. And even though I have a picture of it with a dragonfly in its talons, it really is a bird predator. So you might think, well, you can have sharp-shinned hawks, even if you get rid of all the insects in your neighborhood, but think about it. The birds that this guy's eating needed insects to become birds. So it doesn't eat insects directly, it needs them indirectly. Since we're talking about birds, let's talk about baby birds. This is a list of the terrestrial bird families in North America that rear their young on insects, and the book will say other arthropods. And those other arthropods largely are spiders that needed insects to become spiders. This is 96% of our terrestrial birds are relying on insect protein when they reproduce. We are so used to thinking of birds as seed and berry eaters. I can pick up any landscape for birds book, and that's what it will tell me. How do I put plants in my landscape that make seeds and berries? And some of the books tell you to put ugly Agnes in your landscape because it makes berries, and the birds do eat them. That's how buckthorn got here. All of our favorites, the birds eat those berries, but only for 2 weeks of the year. When they're reproducing, those berries are coming out. They're not raising their young on berry, they're raising them on insects. So, I can generalize and say this brown thrasher is not going to be able to rear its offspring through to maturity if it's in a land without enough insects, and that is such a land. All right, if we're going to make viable food webs in our yards, in our neighborhoods, how many insects do we need to make that work? We need a lot. And it was the Carolina chickadee that told me that. I put up this little nest box in my backyard, set up my camera so I could take a picture of whatever they brought back to the nest. And the first thing I discovered is that they brought back caterpillars. It's the only thing my chickadees fed their babies, which is a surprise. Chickadees eat seeds all winter long, but not when they're rearing their young. They're rearing their young on caterpillars. I also learned that the male and the female cooperate when they're rearing their young. Which means they can bring back a caterpillar to the nest once every 3 minutes. That's a lot of caterpillars. In one 27-minute period, they brought back 30 caterpillars. How do they do that? By bringing back more than one at a time, sometimes a whole bunch at a time. And they do this from 6 a.m. to 8 p.m. In a 3-hour period, they brought back 17 species of caterpillars. Now this is in my yard. Chickadees forage about 50 meters from the nest. They're not flying 5 miles down the road to the nearest woodlot. So if you don't have enough caterpillars near where your chickadee nest box is, you're not going to have nesting chickadees. So they brought back 17 species, and that's an important part of the story here. If I had 1 or 2 species of caterpillars in my yard, and it happened to be a down year where they were in that down cycle, there wouldn't be enough to allow these guys to reach maturity. So that food web would collapse right there. But if I have 17 species, and I actually have a lot more than that, there will always be something that will be abundant enough to bring these guys. If we go to the book and we look up how many caterpillars a chickadee brings back to the nest every day, it's between 390 and 570. And they do that for 16 to 18 days before the young fledge. So if we get out our calculators, that's between 6,000 and 9,000 caterpillars required to make one clutch of chickadees. So now we're getting an idea of how many insects we need in our food webs. If we want simple little things like chickadees. This is a tiny bird, 1/3 of an ounce. I think that's 4 pennies worth. What if we wanted a red-bellied woodpecker that's 8 times bigger? How many caterpillars does that take? How close are our yards to making this much food? I'm not sure how close your yards are, but I've been measuring them where I live. And so far we've looked at 66 houses in 22 different developments in southeast Pennsylvania, Maryland, and Delaware. And what we have found is that 92% of our suburban landscapes are lawn. Very few plants in those landscapes. Out of the plants that are there, 74% of the species are out-of-towners, are non-natives, 79% of the individual plants. So essentially 80% of the plants are not contributing the caterpillars to my chickadees' food webs, and 9% of those plants in these residential neighborhoods are highly invasive. Not because they've invaded these landscapes, but because the homeowner has planted them. Things like Bradford Pears and burning bush and barberry and miscanthus and all of those guys. So we really have, we're living in barren landscapes with plants largely from Asia that are not contributing to local food webs. We also measured the amount of tree biomass that remain in our suburban developments, and compared to nearby woodlots, only 10% of the trees that could be there remain. So in building our suburban neighborhoods, we've thrown out 90% of the tree biomass that used to be there. And of course, that's what the chickadees are foraging. We've thrown it right out the window, which is why when we look out the window, we typically see nothing moving anyway. And we have seen nothing moving for so long, we think that is normal. We've labeled that good land stewardship. And now in many communities, if you landscape in a way where you see something, where you actually see something moving, you're fined by your civic association. So we got a long way to go. This is my neighbor's house. He owns 10 acres, and every plant that he's put on his property is an out-of-town, is a non-native. How have we gotten here? Well, we've gotten here because of what I already mentioned. We see plants now as decorations. So, if we're going to just think of plants as decorations, if we're going to forget about all of the important ecological roles that they should be performing, we can go all over the world and find the prettiest plants, and then we can put them in our yard. And that's essentially what we have done. When we choose plants for landscaping, they've got to be beautiful. Maybe they can be screens or anchors or focal points, but it's all about aesthetics. We haven't considered the ecological roles at all, because remember, we thought nature was happy someplace else. We didn't have to do ecology at home. But if we include as criteria the ecological roles that plants are performing, we can balance this. We can have balanced functional ecosystems at home that are also beautiful. And this is the most important thing I think our plants have to be doing, and that is contributing to local food webs, because if they're not, you have nothing else. And that hardly is a balanced ecosystem. So I'm trying to convince people to think of their yards as opportunities to make the ecosystem services that we all need. There's a family that lives in that house, presumably, and if they're not making all of the ecosystem services they need every day at home, they're going to have to borrow them from someplace else. And we used to borrow them from nature, but there's not enough nature anymore. Can they borrow them from their neighbor? I don't think so, because he's not making enough either. Can they borrow them from the open space in their township? Not if it looks like the open spaces in the townships where I come from, where they are golf courses or soccer fields or a vast lawn with a paved path that goes in a circle around it so people can walk their dogs. That's an open space because it doesn't have a building on it, but it's not good ecological habitat. So we've got to make the ecosystem services right at home. If we want to make clean water at home, we don't want 92% lawn, because lawn makes dirty water. It doesn't encourage infiltration into our aquifers either. If we want to sequester carbon, and we do want to sequester carbon, we don't want just 10% of the trees that sequester carbon that we could have on our yards, and we don't want them to be short-lived ornamental trees that are going to fall over in the first ice storm and release all the carbon that they have just sequestered. These are Bradford Pears, and I should go and look at this tree. After this winter, we've had 2 or 3 ice storms. I bet they're laying flat right now. And of course, if we want to reestablish food webs, functional food webs in our yards, again, Bradford Pear and things from outside of our local food webs are not going to do it. Now, does that mean that your yard has to be 100% native in order to accomplish this? No, it doesn't. But I want you to think about the plants, each one of the plants in your yard, about what it's doing and what it's not doing. The example I like to use is Crape Myrtle. You probably don't use a lot of that here, but if you go a little farther south, that's just about the only plant you can find. You know, Crape Myrtle, even though it's from China, is the state tree of Texas. I drove to to Norfolk, Virginia a couple of weeks ago along the eastern shore, a couple hundred miles straight road, and lining the road all the way down are Crape Myrtles. Why? Because it's a beautiful plant. It's a beautiful plant. I counted them as I went, and when I got to 35 million, I stopped. But it's not contributing anything to local food webs. It's got beautiful bark, beautiful flowers, but it doesn't make any insects. So, what is something that's beautiful, but essentially biologically inert? I always think of that as a statue, but the question is, how many statues do we want to have? One or two, but maybe not this one. So, if we want to restore the ecological integrity of landscapes like this, we have to do two things. We've got to put the plants back, but they have to be productive plants. It can't be just any old plant, or it's not going to work. And you might think I'm going to suggest that if we use native plants, all will be well. But we made a list a few years ago. This is a ranking of all of the plant genera, the woody plant genera in the mid-Atlantic states. And the little numbers after each plant genus are the number of species of caterpillars, the number of species of bird food that each one of these plant genera can support based on literature records. So memorize that. The first thing you're going to see is that there's a huge difference between number one and many zeros in the end here. But the other thing, the thing this list allows us to do is choose any two plant genera and compare them in terms of their value to local food webs. So let's do that. Let's compare tulip tree, Viridendum tulipifera, very common tree in the eastern forest where I come from, a native. Let's compare it to oaks, genus Quercus. Genus Quercus, by the way, means, the word Quercus means fine tree. And it is indeed a fine tree. If we go to our list, we see that Quercus is number one. 557 species of caterpillars on oak trees just in the mid-Atlantic states. It's the most productive tree we have. Compared to tulip tree, supports 21. 557 versus 21. These are both native plants, but there's a huge difference in their productivity. So if you had space for a single tree in your yard, you were trying to decide, should I plant an oak or should I plant a tulip tree? That's what this list is for. And by the way, even though this list was made for the mid-Atlantic states, the Forest Service has funded us to make a list for every state in the Union, and they also want us to do it by county, and they want us to do it by Christmas, too. So we're working on that. But someday, you should have a list for Iowa that will give rankings, and then we'll be able to compare. Is Iowa just like the East? And you'll be able to use it just like this. What about redbud? You guys plant redbud? Yeah. Great native plant. Why is it great? Because it's beautiful when it's blooms. Still think of native plants just as something that's either pretty or not. Well, this is pretty when the blooms are out, but what's its contribution to local food webs compared to something like black cherry, which typically is not in the native trade because landscapers don't like it. They don't like it because they say it's messy, meaning it makes more black cherries, and because it gets tent caterpillars, meaning it supports biodiversity. If you hire a landscaper and turn them loose in your property, which is what my neighbor does, chances are the first thing they will do is chop out all the black cherries and tell you, you don't want these plants, they're weeds. Weeds are plants out of place. And if you're trying to reestablish a food web in your yard, black cherry is not out of place. So I beg to differ, it is not a weed. Let's go to our list. It turns out black cherry native Prunus is number 2. 456 species of caterpillars, native Prunus, compared to redbud supports 19. 456 versus 19, again, huge difference, even though they're both native genera. If you keep the black cherry in your yard, or American plum, or pin cherry, or any of the native Prunus, you're going to get a plant. It may not be the most beautiful plant on the planet, but it's going to produce some of the most beautiful creatures on the planet, like the Cecropia moth. Its favorite host plant is black cherry. This becomes part of the life in your yard. It becomes a feature of that tree, and it becomes a way that you can get your kids outdoors, get them excited about what's happening right in your yard. Tell them to go out and find the Cecropia moth, find the larvae, find the cocoon, find the eggs. There's some part of that life history in your yard all year round if you have their favorite host plant. If you build a butterfly garden, of course you want tiger swallowtail. What is their favorite host plant? Their favorite host plant is black cherry. Most people put in butterfly gardens, and they put in a whole bunch of plants that make nectar and hope they attract butterflies from someplace else. But who's making the butterflies? You need larval host plants to make butterflies, and most of the larval host plants for most of our butterflies are woody plants. They're not the flowering plants that provide the nectar. So what you really need are nectar sources and the woody host plants. So don't forget that. Don't rely on the woodlot, again, 5 miles down the road that's going to be a development soon to make your tiger swallowtails, make them right at home. And you get lots of other things if you keep your native prunus in your yard. You get the beautiful Io moth, and it's equally beautiful larva. You don't want to pet that, but it's beautiful. You get the dowdy pinion. Who would not want the dowdy pinion? You may not have noticed, but many of the caterpillars that the chickadees were bringing back to their nest were dowdy pinions, and they are specialists on black cherry. You get the yellow-shouldered slug, you get the crocus geometer, the paddle caterpillar, you get the red-spotted purple, which is a specialist, another specialist on black cherry, and its larva that looks like bird gum. You get the Peruvian moth, and its beautiful larvae. You get the purple-crested slug, there's the crocus geometer, the spotted petales, the saddleback caterpillar, the wavy-line heterocampa. You get the hourglass. I'm having a senior moment. You get whatever that is. I know this. We'll come back here. It's one of the fir trees. White fir. You get the spiny oak or the spiny rose caterpillar. You get the tufted bird dropping, and the lunate zales. You get the yellow-haired dagger moth, the long-winged dagger moth, the ragflesh dagger moth, the interrupted dagger moth. You can make a dagger moth collection. You get nascent slug, and then 400 and some odd other species of caterpillar. If you keep some native plants in your yard. What about enough? You put that oak in your yard. You get the puss caterpillar. You get the polyphemus moth. You get the buck moth, the white-marked tussock moth, the saddle prominent, double-line prominent, white-dotted prominent, the checkered fringe prominent. You get the laugher. You get the lace cap caterpillar, the oblique heterocampa, the white blotched heterocampa. You get the variable oak leaf caterpillar, the banded tussock moth, the hickory tussock moth, the spiny oak caterpillar, the banded hair streak, the yellow net caterpillar, the smaller carassa, the unicorn caterpillar, the crown slug, the hag moth, which thinks it's a tarantula. You get the streak dagger moth, the red humped oakworm, the confused wood grade, the spun glass slug, and 500 and some odd others. I think that's the coolest caterpillar in North America. You know where I took every one of those pictures? In my front yard. Yes, you are allowed to have productive plants in your front yard. We always talk about backyard habitats, which implies this is all so ugly we have to hide it in the backyard. It's not. These are on oak trees and they're beautiful. So what does a biodiversity-friendly suburb look like? There is no one answer to that, but this is the most important thing that we need to do. We need to build biological corridors that connect those isolated habitat fragments. And if we do that, they're not isolated anymore. And if they're not isolated anymore, the populations within them are not tiny anymore. So when they fluctuate, they will not disappear anymore. Where are we going to put these corridors? Let's put them in the area that's now in lawn. Do we need 45.6 million acres of status symbol? Probably not. So let's put them in the area that's in lawn, and let's build them out of the plants that are most productive at supporting food webs. So let's do that by flip-flopping the landscaping paradigm. We have followed forever. We have built our house, then we put in a flower bed, typically right next to the house, a few trees here and there, and we're exhausted, no more landscaping, so everything by default becomes lawn. All right, that's the old way. Let's turn that around. Let's build a house, and now figure out where we do want lawn. What is lawn good for? Lawn is good for walking. Turf grass is the perfect plant to walk on without killing it. So next thing you want to do is figure out where do you want to walk in your yard. You're not going to. I look at where my neighbors walk. 10 acres. Where do they walk? Nowhere. Never outside. But let's say you want to get married in the front yard. You have to have lawn there. You want to walk to the backyard, nice grass path, throw the frisbee, have a barbecue. Whatever you're going to do, wherever you want your lawn to guide you through your landscape, that's where the grass goes. Then everything else by default becomes heavily planted. Tall plants in the back, short plants in the front. And this is such a landscape design paradigm shift that it really becomes the design challenge of our times. How do we get this many plants in our yards without it looking wild and messy? If you've ever been to an arboretum, you can see that it can be done, because they have lots of plants there. Many of them are from someplace else, but these can be largely native. And if we do that in half the area that is now in lawn, let's say we got 40 million acres in lawn, we're going to cut that in half, we can build a new national park. We're going to do it at home, so we'll call it Homegrown National Park. And it'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, plus Grand Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. You add them all up, and it's still less than 20 million acres. So let's do that. Let's take areas that look like this, turn them into that. Let's take this design, this mulch sculpture, turn it into something that is living. These are all native plants. This is a corporate landscape designed to invite the employees at noon to get sunburned. It could be a lovely landscape like this. And you know, research has shown if you spend just 15 minutes walking along a path in a landscape like this, there are measurable medical benefits. Your blood pressure drops, your stress hormone in your blood, your cortisol drops, your cancer is cured, you don't get divorced anymore. All of those things happen. I think you win the lottery too. That's an active area of research, all the medical benefits from being exposed to nature, and much of the literature was reviewed in Richard Blue's second book on nature, called The Nature Principle. So it's 2 years old at this point, but if you're interested in that literature, it's reviewed right there. And when you create landscapes like this, you introduce three things into your life. You introduce surprise, anticipation, and entertainment. By surprise, I mean that you cannot walk into a landscape like this without seeing something you didn't expect to see. And that's true for me. You know, we've been in our house 13 years. I go out all the time, and I always still see something I didn't expect to see. Very rewarding. Anticipation. You can throw away your calendar and anticipate what nature is going to do, because it does it on schedule. It does it every year, and when it does it, it renews the spirit. It really does. We start spring at home at our house when the woodcock comes. My wife called me up the other day. It was March 1st. There was still snow everywhere, and she said, "Guess what? The woodcock is here. He's doing his rotating dance." And you know, that just makes us feel good. I don't know. Maybe we're just strange. So that's when spring starts. Spring really gets going when the toads start to sing, when the house wren moves into its house. Midsummer starts when the white line sphinx starts to pollinate the evening primrose. And of course, fall starts when juncos arrive. Now, you live in a different part of the country, you can set your own calendar, but this is, you anticipate this. You can, has it happened yet? It will happen, and then it makes you feel good. Entertainment. It's a bottle brush buckeye in my yard. I walked by it this summer, and 17 swallowtails flew up from it. You can't walk through a cloud of 17 swallowtails without a smile on your face. You can't do it, I guarantee it. You can have a grass path, or a woodland path in your yard. That could be the edge of your yard. But look, it curves around, disappears from sight. It makes it look like you own the rest of the world, like you're Ted Turner. And now you don't have grass back here that you have to mow. You've got appropriate woodland plants, and your neighbor is not going to be upset that you're not mowing anymore because he can't see you anymore. But if you convince your neighbor to do the same thing, now you've got that connectivity that I'm talking about. It connects with the woodlot here and the woodlot over here. And you've just stopped that species drain from your local ecosystems. Now here's a homeowner that put the house into essentially a woodlot without cutting them all down. So that's a good first step. This is a tulip tree monoculture, by the way. Very common at home because we've logged out all the valuable trees. So one thing they could do is diversify this with trees that are a little higher productivity. But it's not what I want to talk about. I want to talk about what they did next, and that is to mow under every single tree. And of course, if you cut the grass once a week, there's nothing alive between the ground and the canopy. Why do they do that? Because society says we love short grass. Why do we love short grass? I don't know. But evolutionary psychologists have some hypotheses. And the ones they like the best is that we spent a lot of time in Africa. And every time we went into tall grass or bushy scrub, we didn't come out anymore. So it was only people that like short grass that left Africa. And of course, what they're really saying is, we want to be able to see to the horizon, to see whether there's any danger. And I understand that. But, research is also showing that is not the case. As you add plants to urban areas, crime actually goes down. There is no bad man hiding behind the dog leg here. So it's something we have to get over. When we're building our biological crime, we want canopy, we want subcanopy, we want understory, we want shrubs, we want healthy forest floor, because there's important components of biodiversity in each one of these strata. We are trying to put the plants back. But of course, these plants are going to make leaves. And those leaves are going to fall to the ground. What's on the ground? Our lawn. So we all freak out. We get out our rakes and our leaf blowers, have them bag the leaves, put them out to the curb as if they were trash or the garbage man. And then we run to Home Depot and we buy mulch, we buy fertilizer, we buy hoses, trying to replace all the ecosystem services we just threw out. What we can't buy are the arthropods that live in those leaves. My son bought a house 2 years ago. In the first fall he was in it, he called me up and he said, "Dad, I've got too many leaves." I said, "Put them in your flower bed. It's the perfect mulch for flower beds." He said, "I don't have enough flower beds." I said, "Exactly." That's how you shrink your yard. You've got to have enough flower beds. Now here's an oak tree where the leaves fell, the homeowner did not rake them up, and it made the perfect medium for a fern garden. He didn't plant any of these ferns. They simply came up because it was moist and a great place to be. So he's done several things here by not doing anything. He's created a sponge. So in the summertime when that downpour comes, it soaks up the rain so it doesn't all run off. He's not adding any fertilizer. The leaves are turning into fertilizer for the oak tree the way they're supposed to be. But he's also created he could formalize this with a grass path that tells, it sends a cue for care to the neighborhood. It says, this is an intentional landscape. I haven't moved out, I still am landscaping. And that's really all the neighbors want to see. They just want to see that you really are taking care of things. But what he's really done, and probably doesn't know it, is that he's created the perfect foraging site for our poor wood thrushes. Our wood thrushes have lost 50% of their population since 1966 because they forage for arthropods and leaf litter, and we keep throwing it out. So nature is what you make of it these days. You can make a lot of it or a little of it depending on how you landscape, whether you're using productive landscape plants or not. And more people are using an increased percentage of native plants in your yard, which has allowed us to actually measure what happens to biodiversity when you do that in suburban settings. This was Karen Burkhart, who's a student I talked into doing this project, and she was very happy about it. She did a great job. She's a great student. She compared 6 houses that were landscaped primarily. None of them were 100% native, but they had a higher percentage of natives, with 6 traditional landscapes, and that's a traditional landscape, by the way, in the same neighborhoods. And she controlled for everything in this study. So the most important thing she controlled for was the amount of plants. So all of the comparisons had the same amount of plants. The only thing that differed was the percentage of native plants. She was not comparing bare lawn with a forest. And she measured caterpillars and breeding birds. She found significantly more caterpillars on the primarily native landscapes, more species of caterpillars, more birds, more species of birds. There were some birds on the traditional landscapes. When she looked at what they were house finches, starlings, house sparrows, which are not from here. A few pigeons thrown in. Those are all invasive species of birds that essentially do well on human garbage. When she took them out of the data set and looked at the birds of conservation concern, where she did this particular study, she got the biggest difference of all, which simply says that the birds that are declining in our suburban neighborhoods respond quickly to this. And that's exactly what we're trying to accomplish. And that was a very good part of this study, the fact that it did happen quickly. All of the landscapes, the redone landscapes that Karen looked at, were 3 years old or younger. So all the things that came to these landscapes colonized them very quickly. And that's good, because we're a society of instant gratification. If it took 50 years for these transitions to happen, nobody would bother doing it. But it doesn't. It happens right away. Final thing I'm going to talk about is what a lot of people worry about the most. If you put native plants in your yard and all these caterpillars come and eat them, you're going to have holes in your leaves. Or I always hear the word, they'll be defoliated. And of course, that's not why we garden. But that will not happen if you build a balanced ecological community in your yard. If you have the native plants, the herbivores that eat them, and then the natural enemies that eat them, and the diseases that keep them under control. If you do that, you will have no more damage on your landscape than if you had all out-of-towners on there. We've measured that and proven that to be true. So here is an example. This is a tobacco hornworm. It was eating one of my tomato plants. I'm going to have to take its picture. So all these cocoons on its back. A lot of people think those are eggs, but those are the cocoons of a little reconded parasitic wasp, the larvae of which have already tunneled out the insides of this guy. See, he's shrinking up like an accordion. And then they tunnel through his skin, spin the cocoon, then they fly off as an adult and find another sphinx moth. He's a type of sphinx moth. This is a pteromalid wasp, which is laying eggs in the braconic cocoons. So the pteromalid is making sure that we don't have too many braconics at our house. And the braconics are making sure that we don't have too many tobacco hornworms at our house. And the tobacco hornworms are making sure we don't have too many tomatoes. So this is a little food web, all in balance here. You might ask, why do we have these natural enemies when maybe you don't? And there's two possible answers. Natural enemies will not stay at your house if there's nothing to eat. So one possible answer is that we have tobacco hornworms at our house all season long in such numbers that there's enough to keep these populations of natural enemies going. And I thought about that. In the 13 years we've been there, we've seen 4, and he's one of them, and he's dead. So that's not enough to keep these guys going. The other possibility is that there are other hosts for these braconic wasps, and that's true. We have 18 species of sphinx moths that these guys hit at our house. And he's the only agricultural pest we have. But we have 18 species because we have the native plants that support them. We have the blinded sphinx because we have black cherry. We have the four-horned sphinx because we have American elm. We have the hummingbird sphinx because we have Viburnum dentatum, native viburnums. We have the hog sphinx because we have grapes. Native grapes. We have the snowberry clearwing because we have coral honeysuckle, the native honeysuckle. We've got the Pandora sphinx because we've got Virginia creeper. And I got Virginia creeper on my back porch because I planted it there. Why would I do that? Because I wanted that moth to come and lay an egg on that plant so that I could take that picture. Because that's how I entertain myself. Well, they come in red, they come in yellow, they come in brown, they come in green, and they come covered with braconic cocoons. They're pretty big caterpillars, and people have asked me, aren't you afraid they're going to eat all your Virginia creeper? No, I'm not. Virginia creeper grows really fast. And in the 13 years we've been here, those are the only 4 we have seen. Why is everything so rare at my house? Because look at all the things that are killing them. It's very difficult to reach maturity at my house. And we have other predators. This is the cogwheel bug. It's the largest assassin bug in North America, eating a fall webworm. Nobody likes fall webworms. This guy's doing his best to keep them under control. And we've got those breeding birds. It's not just chickadees that are bringing back hundreds of caterpillars a day. This is our friend the bluebird. All of the birds are bringing back hundreds and hundreds and hundreds of caterpillars and other types of insects to their nests when they're breeding. It is very difficult to have an insect outbreak when you have breeding birds at your house. But it is very difficult to have breeding birds at your house if you don't have enough insects to support them. And that's why I can look at my other neighbor's yard. This is a little woodlot that he has. And look, it's not defoliated. If I went up and looked at the leaf, any single leaf there, I would probably find a little something eaten out of each one of them. But you can't tell that from a distance. It's still aesthetically pleasing. It is an ecological balance. So this is a grassroots approach to conservation that I've been excited about for several years now. For exactly that reason. It's something we can all do on our own, right away. We don't have to get the government involved, which is great because they're really busy these days. We don't have to send money to Brazil to save the rainforest. We've been doing that for 30 years, and they're still chopping down the rainforest. Just read an article coming out on the plane about how terrible it is down there with the Amazon. Let's do some conservation right here in the good old tundra zone. And if we do that, it works. As a single individual, you have the power to change something and see the results. And there are very few environmental issues where a single individual can actually do something and see the results. But you put a plant in your yard, something will come and start to use that plant. You've got increased biodiversity. It's motivation to do it again.